Why are GPUs so complex? Let's find out. GPUs have massive hierarchies in both memory and execution. Memory spans from global memory down to registers, with each level trading capacity for lower latency. Execution spans from grids to blocks to threads, defining how parallel work is expressed. Each hierarchy solves a different problem, yet together they can feel overwhelming. Why is it so complicated? To understand this, we must go back to the origin of computation itself. Before software existed, ENIAC had no stored programs. Control was physical, implemented through wiring and switches. The machine's behavior was defined by cables, not memory. Changing the algorithm required manually rewiring the hardware, a process that took days, a radical idea. John von Neumann proposed storing programs alongside data in memory. A processor would fetch instructions and data over a shared path, execute them, and write results back. This abstraction created software as we know it today. As semiconductor technology improved, processors became dramatically faster. Clock speeds increased by orders of magnitude, and arithmetic operations became cheap. Memory systems did not scale at the same rate. Latency improved slowly, and bandwidth lagged behind processor demand. As the gap widened, processors increasingly stalled, waiting for data to arrive from memory. Execution units sat idle. The system was no longer compute-bound, but memory-bound. This is the von Neumann bottleneck. This perspective makes three distinctions clear: one processor, one memory, one shared path. This setup is simple and flexible, but it is fundamentally constrained by the memory bottleneck. GPUs embrace hierarchy. Thousands of lightweight cores operate in parallel. Registers and shared memory are positioned extremely close to computation. Global memory is accessed in bulk and amortized across many threads. The programmer manages complexity so the hardware can avoid the bottleneck. Neuromorphic systems aim to blur the separation between memory and computation. Inspired by biological neurons, state and processing are co-located, and computation emerges from local interactions rather than instruction fetch. Performance does not come from faster processors alone. It comes from reducing the distance between data and computation. GPU complexity is not accidental. It is an architectural response to the cost of separating memory from compute. By moving computation closer to data and exposing hierarchy to the programmer, GPUs turn a fundamental limitation into scalable performance.